Hi, hello.
Hi,
What's your good name?
Mashhood. I'm from Khalifa University.
Okay, great.
Yeah.
So, what you are going to share with us about your product and your research?
I will explain to you the projects we are doing in agriculture from the perspective of AI and robotics to make
Okay.
autonomous systems for agriculture system in UAE.
Okay, great.
So the first project I will show you is for the pollination. As you know, in UAE the weather gets very hot, and the honeybees cannot survive over here. Even if you are farming in greenhouses, even if you are farming in greenhouses, if you put the honeybees, they won't survive because of the temperature. So you need to do some manual pollination. So what's the traditional way to do it? Was to have a toothbrush and put pollens on it, and you go and interact with the female flower plant and rub the brush on it. But this was a laborsome task. It takes a lot of time, and when you are working in UAE, you see there are a lot of lands of agriculture. So it would take a lot of time to do this pollination. So we automate it using our Husky robot, and you can see it has a brush over here and the camera. This camera detects female flowers where they are, and it will calculate the trajectory of the robot, and then it will reach to the flower of female. Like right now, it will detect there is a female flower over here. It will go and start to do the pollination. Mainly use it for the palm tree. This is one project of ours. The second project that I'm going to show is this wearable device. This is, before telling about it, let me tell you, this is a unique and novel idea that we have a US patent filed on. So what it is? So you know, in agriculture, to assess the ripeness, you need to know before harvesting them. So to increase the shelf life. So there are many variables, like changes of colors and this kind of stuff by smell. But some fruits, such as kiwi, avocado, or any other kind of fruit, they don't change their color. So what's the criteria to know if they are ripe or not? So one of the way is to know the firmness. And for firmness, they use a penetrometer device. For penetrometer, you cut the fruit, insert a probe. That probe has a spring mechanism, and it will resist. And based on the resistance, it will tell you how much firm it is. But now, who will want to buy a fruit that has a punctured hole inside?
Correct, yeah.
This was one solution. There are also other camera-based solutions, but they cost a lot of money. So we came up with an idea. The story over here gets interesting. Whenever you see humans, as humans, whenever we buy a fruit, what's the first thing we do? We grab the fruit,
Yeah.
and we try to press it from our thumb.
Correct.
And because we have the sensation, and based on the sensation, you get to know how firm it is. But each human have different kinds of sensitivity, and but they cannot be transferred to another human. Maybe for me it's hard, maybe for the other person it will be soft. So we make a tactile sensor. We are putting a tactile sensor on the thumb, and you wear it in your hand, and you press it, and you see over here this digit-based tactile sensing. It will record the human palpation and use our AI model inside over here, and then predict the firmness. So based on this technology, you don't need to pluck the fruit even from the tree. So you imagine a farmer wearing it, going into the farm, and just using this device, pressing it, and getting the firmness. So it becomes another quality meter to be evaluated, and is non-destructive.
Okay, but there are several fruits where large number of fruiting is there on single tree.
Yeah.
So do we need to touch each and every fruit for
Yes,
that?
you are asking the right question. So over here we deployed the same technology in a robot gripper. You can see it has a tactile sensor over here.
Okay.
And the robot will, as I said, we are working on autonomous agriculture. So the robot using this gripper will go and press it and know the firmness and record it. And then you will get a dashboard-like system that will give you the whole analysis and which to harvest. This enables to accurately harvest the fruit, and it will give you a long shelf life.
Correct.
So this is one project, second project. The third one I'm going to show you is on the blueberries. As you know, UAE grows many blueberries, and they need to know the yield estimation, like how many blueberries are being grown in a greenhouse, and which is ready to be plucked, like when should we harvest. So imagine one person or a labor that goes to the greenhouse, and they start to count how many blueberries are there. So imagine it will take a whole day for one person to count and tell which is a ripe and overripe stage. So we need to automate this process. So to do it, we have a drone, and it has a AI-based algorithm, and you can see on the top there is a camera over there, and this drone will fly in the greenhouse, and it will automatically do two things. One is that it will count how many blueberries are there, and the second is it will calculate the ripeness stage, and the ripeness stage goes from stage 1 to stage 6. So
Okay.
within minutes it can do this. Now imagine if you have hundreds of greenhouse farms. Instead of doing one man per farm, it will take more than one day. So you have a drone, you are covering all of them, and it will fly autonomously.
Correct.
You need to manually operate.
So my next question is like, whether this is commercially viable option. I mean, like whether we started doing the
Yes.
implementation of this
Yes.
technology.
Actually, this have been implemented. 1, 2, 3. This have been implemented. But these are just the 3 projects. Over there, you can see we have a lot of other kind of robots that are doing many agriculture factors, and we are going to create the UAE autonomous greenhouse.
Okay.
So industry is so excited for this one because they are addressing the solution. They are addressing the problems that they are facing right now, and these problems came from the industry. And right now we are in the phase. We have the US patents. We are now working on to make them in a commercial product.
Okay.
So they can be deployed in these greenhouses.
Correct.
So it's not just addressing the local solution, but it will be also using. The farmers will be using.
Okay. Thank you very much. I appreciate. Okay. Bye bye.